In today's tutorial we have again a chemistry riddle. The task is to find a pathway, a synthetic pathway, starting from adipenoic acid, diethyl ester, and finally ending up at this phenylcyclopentene. Well, try to solve that problem first by yourself and then listen afterwards to the solution I will offer. Well, one idea one could have is, what about a radical cyclization? It could be the idea to use sodium sand forming a cation radical here, a cation radical there, and this would then cyclize, giving after hydrolysis this double enol, which then will tautomerize to this 2-hydroxycyclohexanone. Well, nice reaction, but doesn't help for achieving here this product. We need a 5-membered ring. Well, if it doesn't work with radicals, then the only way to get this reaction initiated, this transformation initiated, is a polar reaction, and therefore we need an electrophilic and a nucleophilic center. So how about electrophilic centers herein? Well, yes, we have here the carbonyl carbon. It is electrophilic, also the other one. And 5-membered ring, we need 5 centers, 1, 2, 3, 4, 5. Here, this center should be nucleophilic, but it could form a 5-membered ring, attacking as a nucleophile this carbonyl group. So we need a nucleophile here. How can we generate that? Well, simply by deprotonation. And alpha to an ester, such a methylene group is quite acidic. So deprotonating here with an appropriate base, this can be, for instance, sodium ethanolate in ethanol, addition, elimination reaction, and what we would get there is this product, the product of an ester condensation. A cyclizing ester condensation is called a Diekmann condensation. So now we have to find a path from here to there, but we could also think about first, how would we synthesize that in the last step? Well, we could synthesize this retrosynthetic analysis from this alcohol, simply condensating acidic catalysis and eliminating water. And this would derive from cyclopentenone. First, adding a phenyl grignard, phenyl magnesium halide, chloride or bromide. Secondly, hydrolysis. So this remains intact under these reaction conditions unless we heat that up. So here are acidic catalysis and delta, heating it up. So we are in need of a ketone. The question is, how do we get rid of this ester functionality? This is very easy. Acidic hydrolysis, elevated temperature, will lead to this acid with a rather short lifetime, because beta-keto carboxylic acids are known to be unstable. They will lose rapidly CO2. One is saying they rapidly decarboxylate. So therefore, this is the reaction scheme that will lead us from here in 1, 2, 3, 4 preparative steps to our target molecule. Thanks for listening.